Hello and welcome back to DCD Talks. I'm Alex Dickins, Content Director at DCD, and today we'll be discussing the many layers of battery resilience with Eric Hill, General Manager for Product and Marketing at CSB Battery. How are you doing, Eric?
Alex, good to see you again. Thanks for having me.
Thanks for jumping on, and I know you're very, very busy ahead of going to Bali next week.
Yeah, I can't wait. It's going to be an exciting show. Looking forward to having some great conversations. AI and power density continue to be the rage.
Yeah, absolutely. Well, hopefully we can tease a few of the things you'll be discussing on a couple of the panels you'll be speaking on next week.
Yeah,
But
for
before
sure.
we get into that, for those who are a little bit less familiar with you and CSB, perhaps you could give a little bit of a whistle-stop tour of an introduction. You know, what brought you into the battery world, and where does CSB fit into the data center space?
Yeah, so I've been in batteries for almost 20 years now. Done various stationary power applications, started my career in telecom and broadband, navigated my way towards recycling and doing more renewable energy stuff. I've done everything from BMS to development to, sort of consulting with various recycling companies, helping with that side. But lately, over the last few years, I've been more involved on the data center side, really focused on providing high power solutions, high power dense solutions, rather. And that's really what CSB's focused on right now. That's our core market is supporting the data center and UPS industry across the board, from small enterprise all the way up to large hyperscalers. AI and power density, like I previously mentioned, that's dominating the conversation. And that's been the core focus for us at CSB, is helping these data centers solve problems around the batteries themselves and using the batteries to solve problems, not just selling a widget, not just giving them a battery that can kind of do everything okay, but more or less getting down to the why, like why they want their batteries, what they want their batteries for, and how we solve their problems.
Yeah, yeah. And it's interesting you mentioned there, about how we're using batteries to solve problems. What I wanted to ask to kind of kick off the conversation was how the industry looks at batteries, because there seems to have been this quite significant shift over the last few years where batteries aren't being treated, just as backup anymore. They're becoming a strategic asset as part of this resilience layer.
Yeah, that's absolutely right. The mindset is really shifting from a customer perspective, from an end user perspective, for being a need to have. Right? They were always there, and some scaled bigger than others as sort of a n plus one or two n scale, but now they're becoming so integrated into the power framework of data center deployments, from small to very large scale. So we are seeing clients really focus on answering those top questions that I just talked about, right?
Mm-hmm.
Not treating it as such a kind of a, okay, I'm going to replace it every 5 years and I know it's there if I need it. No, they're actively finding ways on how they use their battery and integrate their battery as part of their strategic operation platform for power consumption, whether it's demand response, whether it's just straight emergency backup, whether it's microgrid, BESS. There's so many different use cases, depending on the chemistry and the scale you go. And it's really refreshing to see that there is sort of that myth being broken around batteries and how we can deploy them, not just to back up but also solve problems. So yeah, that's been really cool from our perspective.
Yeah. And when it comes to, the reasons behind this, shift in thinking when it comes to batteries, we know grid constraints are putting a lot of pressure on. You mentioned obviously AI demand, densification. There's also sustainability pressures that people are thinking about. But,
Right.
Whilst there's, a lot of kind of push to do this, are customers rethinking batteries, not only because they kind of have to because of the power environment, or, but there's options, because they want to, in terms of, actually profitability paths from batteries if you use them in the right way.
Yeah. That's something that we saw early in my career when I was on the renewable side and on the
Well,
utility
okay.
generation side, where customers would use on-site deployment for batteries for revenue generation, potentially, right? Ancillary services, where if you have those feed-in tariffs that are becoming more rare and rare as these days, but when you enter into certain PPA agreements, there are potential options there for a customer to use their battery as a revenue generating asset. Obviously, you don't want to take away from your power needs on site, but if you have excess capacity, sometimes the utilities will allow you to, you know, they will purchase that power from you or that storage capability from you. So again, typical battery answer. You guys hear me, it's like a broken record, but it depends, right?
Mhm.
It depends on the site and what you're using the battery for, but it's definitely an option. And it can be considered if you have the right conversations with your utility.
Mhm. And when it comes to what you're using your battery for, more and more batteries are going to be tested by AI loads as we see more and more, come online.
Right.
When we're talking about kind of battery resiliency, what impact is AI really having? Obviously, we've got training workloads and then inference workloads, which are a lot more, they swing a lot more. But yeah, what are you seeing?
A typical AI workload on the learning side is very spiky and cycling, very what we call microcycles, where there's a
Mm,
shallow sort of discharge and recharge, anywhere from 1 to maybe 5-10%, depending on the battery size and the workload. And that can happen over multiple times a day, right? And so there are certain chemistries that are inherently better at doing that can handle the high power load along with the microcycling. And depending on that demand response curve, it can vary, basically on the load and the workload and the requirement. Again, we liken that to what we found in the renewable side was a demand response, right? So on a demand response side, you'd have voltage sags and spikes, and you would need a battery bank to absorb those, or a super cap or something to absorb those voltage sags and spikes to keep your equipment running and to keep everything operationally sound. And AI workloads are very similar to that, although we see it in much larger and longer scale. And so, yeah, it's really coming down to the chemistry type that you select to handle those inference workloads learning workloads that can handle that, over time.
Yeah, yeah, absolutely. And when it comes to batteries, there's sort of traditional view on them being part of the kind of emergency backup system.
Right.
But do you see them becoming part of kind of more your everyday energy management strategy in the current climate as well?
Oh yeah, no, absolutely. It will definitely be again fully integrated with that ecosystem, especially as we go to higher voltages. Right? We hear talk of Nvidia starting to deploy their 800 volts DC structure at certain locations, and they have partnerships with hyperscalers that are moving, you know, the power closer and closer to the rack. Right, and that will only drive efficiencies up as well too. It's not going to be solve all problems for everybody, right? Because with higher voltages does come some different safety requirements, different code jurisdiction requirements, but seeing that natural evolvement in the market move from becoming, like we talked about, just having a battery, there versus an actual integrated asset is
Hmm.
only becoming more prevalent. And more and more of the conversations we have today are focused around solving that problem to integrate the battery bank as part of the power ecosystem solution, where it's not just sitting there waiting to be used. It could potentially be used for whatever sort of energy management requirement needs, right? Rolling blackouts is becoming a thing in certain parts of the world. So you need a really robust battery that's not only high power, but also high energy so it can last for hours at a time, depending on the utility that you're deploying with. So yeah, I mean, it's definitely a really exciting time for us in the battery world because we're seeing so much innovation come into this space now around the energy management platform. I've seen more innovation in the last 5 years than I have in the previous 15. So it's been great.
Yeah. I mean, I think the way you describe it, it's kind of easy to imagine, the growing role of batteries in these kind of future architectures, which include on-site
Right.
generation or microgrids or, a path to renewables as well.
Right.
Obviously, kind of part one of this conversation is very much focused on the infrastructure and the kind of the stuff we're talking about day to day, but there's other elements to the battery resilience story as well, which I think are probably worth acknowledging. One of which makes which I think people see in every element of their lives these days is supply chains and the knock-on
Right.
impact on availability of raw materials down to manufactured products and indeed the cost of them as well.
Right.
When it comes to battery supply chains, and again, we're talking about a myriad of different chemistries and different metals that you're going to need for their production.
Right.
How much volatility, is there? And again, we're also seeing huge appetite from different demand centers, right? Like EVs, grid
Right.
storage, telecoms, etc. Should we be concerned, and how much attention should we be paying?
It's something that should definitely be closely paid attention to. Most of these large operators now have their, I mean, well, they've always had purchasing and procurement departments, but they're becoming more and more focused on the commodity side because not only do batteries require rare earth elements, depending on the chemistry, there are other components that go into a battery construction that are part of the broader supply chain. And you're starting to see more and more people take notice of that because costs are going up across the board, right? Depending on the rare earth materials, the accessories, the supplies that go into building any kind of battery chemistry. And it comes down to how do you properly mitigate those supply chain risks, right? Having
Mhm.
multiple sources of supply, having strong, proper agreements in place with your vendors, building inventory on non-perishable things, those really go a long way. But yes, it is something that our customers and our mutual customers in the data center space should be paying very close attention to.
Mhm.
Backlogs are continuing to increase across the board. Demand is continuing to go up. And so, yeah, we always help to mitigate some of those risks on our side as well too by having different sources of supply, moving things around as we need based on production.
Mhm.
But yeah, it's definitely a key element that needs to be addressed. I always tell my cohorts in the battery industry, build more batteries, build more batteries. Which is a strategy that it seems like most people are taking now.
And looking as we like to in these discussions, take a sort of slightly forward-looking stance. When we're thinking about battery innovations, are there any things coming down the pipe or any market indicators that our audience should be paying attention to make sure that they can embed resilience into their business in the best possible way, really?
Right. Well, with specifically focused on the data center side, it's coming down to obviously AI is dominating the conversation, which means higher power densities, longer lasting batteries, product that can also support microcycling for those AI learning models. We're seeing that. We're also seeing to continue to, the small enterprise and some of the legacy data centers that are still make up the majority of the population are still really focused on emergency backup, although they're starting to integrate more around BESS as well, looking at on-site generation, microgrid development. And so, yeah, I mean, it's from a chemistry standpoint, from an evolution standpoint, we're really looking at moving towards maximizing power density and also starting to integrate cycle life, right? Because
Mhm.
when you develop a battery, there is no one perfect chemistry that solves all your problems across the board, right? It
Mhm.
really comes down to the what you want your battery to do question that you guys hear me talk all the time. So yeah, I mean, focusing on the power density, scale, we're seeing certain chemistries continue to evolve on that side across the board too. It's not just lithium ion, right? Lead acid's making a lot of really good strides
Yeah.
in improving power density. You're starting to see other, niche chemistries evolve that are emerging from this whole evolutionary scale, and that's just coming from pure demand, right? So
Mhm.
focusing on high power, cycling's coming into the equation, right? Because if you are off grid or if you do disconnect from the grid, you do need a battery that can handle a discharge and then a full recharge. That's considered a cycle. Some technologies cycle better than others. So, finding that blend or trade off mix between high power and high cycle is going to be really important going forward.
Mhm. One element which I wanted to look at in a tiny bit more detail as well. We talk a lot about what batteries can do, but there are obviously limits to all kinds of technology. And
Right.
with the kind of scale at which we're deploying batteries at this point, the demands being put on them, and loads which as you described, the kind of the volatility, the spikes are going
Right.
to put pressures, or pressure on batteries that the scale of which we probably haven't seen before, the duration we haven't seen before. So when it does come to the safety question, and kind of operational robustness, with batteries, are people asking the right questions, or is there a little bit more we need to think about when it comes to how we safely integrate and then operate these technologies over time?
That's a great question. And I'm glad that we talked about that because safety is paramount in everything we do at CSB, and all battery manufacturers as well too consider safety to be paramount,
Mm.
right? And it's no secret that there are some chemistries that are inherently more safer than others, whether it's due to operational issues that happen, manufacturer defects. I mean, you can go across the board, but it's really important that operators have those conversations with their first responder teams,
Mhm.
with their local code enforcement jurisdiction people to understand what the code requirements are in their area because they vary across the board globally depending on where you're at. So having those conversations up front are really important. There is a common myth in the battery world, where they say no thermal runaway. Well, that's inherently false. Any battery can go into thermal runaway. Just more batteries have higher tolerance for it.
Mhm.
depending on how they're used, right? So, for example, like lithium iron phosphate, for example, there's a lot of comments around the no thermal runaway. It is inherently much safer, but
Mhm.
it does have a much higher thermal runaway point. If you ever got it to that point, it could potentially still do that. That's just one example.
Yeah.
But it's important to understand that different chemistries have different trade-offs, right? And
Mhm.
so understanding those safety requirements are very, very important,
Mhm.
and how they integrate with your system as well too, because there are different certification requirements for integration with your system.
Yeah. And actually, speaking of, myths or, sort of areas that people perhaps are missing a little bit of a trick on. You outline one there, but is there anything else when it comes to battery resilience or indeed, kind of broader power resiliency that perhaps gets overlooked sometimes or you think is a little bit of a myth in the industry?
Again, the one I just mentioned too around the thermal runaway point is a big one, right? Just understanding the operational physical limits of your technology is really important. I mean, because physics do play a part and chemistry do play a part in your battery deployment. Understanding those true limits and what's around the operator's unique system is very important. A one size fits all approach is a common myth, right? We still have some operators and some um, you know talking points out there that talk about, hey, my battery will do this, 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 and solve all your problems. No, that's not necessarily true. Some do solve them very well, other
Mhm.
than other chemistries, but there's always a trade off, right? It may
Right.
do this really well, but it won't do this really well, right? You may have a high power battery, but it won't cycle very well, or you might have a high cycle battery, it does low power density, right? So finding that balance between the two is really, really important, depending on your site and how you want it to actually operate with your system.
Mhm.
Those are the two most common ones we see today that we try to help educate and just inform, customers, right? And see if, our technology is a good fit, but there might be another technology out there that would be a better fit for their application.
Yeah, absolutely. Well, Eric, we've run down the clock. I don't know where the time's gone, but I really appreciate you coming on and chatting us through all of that. I think we covered a fair bit of ground.
No, for sure. And yeah, Alex, thanks as always. I mean, happy to come on here and talk batteries at any time. And yeah, thanks for having me.
Well, massively appreciate it. And thanks to CSB for partnering with us on this episode. But finally, thank you to our audience for tuning in. If you do have any questions, please do reach out to Eric and the team at CSB. They'd love to hear from you. But other than that, we'll see you next time. Goodbye.